today investigate my graphic card. Regarding of this, I want to make sure that everybody sees the screen, so I put the priority on the screen. And before I start benchmarking, some couple of things that you should know about. This is the RTX 4090, and it's totally 100% custom water cooled. So both backplate and the actual GPU PCB is the water cooled. So it is in a sandwich water cool system, and the original TUF has these specifications. So actually the clock speeds are announced there, memory clocks, and effective transfer rate and bandwidth. 4090 is the current flagship as let's say consumer product, and support all the latest technologies what Nvidia can offer. So let's start benchmarking for now, and a couple of things that you know that I'm streaming currently with my other computer, so I just transferred the screen information to the secondary PC using HDMI, so the bandwidth requirement for us is not that intensive actually than single PC streaming. So basically all the encoding happens to be on my secondary PC, so there's not that much stress, but still, let's say how much I currently how much I got the load on my GPU. Let's change the skin. Now you see full screen. So this is currently what is my graphic card running, and I forget to actually then open the GPU thing. Sorry about that. So you get the verification that it's RTX 90, 4090, and all the information. And here you can see now the actually current situation. If I close this, I see all the data. And yeah, I wonder where, well, should I just put all? Let's put the, okay, basically I just let more power, but no overclocking, just basic more power. This is just how we start usually testing. You can even drop fan controlling is not relevant for me since my graphic card doesn't have a signal to control my PC fans. I have different software that controls. It's by BIOS based, and yeah, checks the water temperature and adjust the fan speed and pumping speed through the fans. I have two 360 radiators. One is the 45mm stick and one is 30mm stick. And I got Arctic P12s as a fans, and I got the D5 pump with 40%, so basically silent. Let's start volley. Put extreme, custom. Actually, I need to put resolution higher. Oh, everything ultra. Let's start running now. How much? hopefully you can see the screen. This is 4040p with borderless window at mode. So let's see. So I changed in my block currently my thermal patch plus minus 8 from thermal grizzly, and I put the dry seed on the graphic card, so no thermal paste at all. So the boost is something like 150 Hz. Temperature goes somewhere 35 to 50. In a GPU, hotspots start from 44 to 56. You can actually compare this if you have somebody who benchmarking just regular graphic card, you can compare how much water cool actually benefits. Usually it's benefiting like 15 to 10 degrees at least. Somewhere memory can be even 20. In overclocking scenarios, that should be also increase in since the water is more, I mean liquid. In this case, water and a little bit alcohol as a reduction of TOC, total organic carbons in TOC means total organic compound. So memory sits in a stable 50 degrees. Okay, there's my points. 7081. That is good reference. Let's a little bit overclocking. So I have couple of settings in here already. I have curved, regularly, 150. Let's start with plus 150 as a core clock and 1000 for the memory. So stable and start benchmarking again. Then benchmark. Let's see what happens in temperatures. Memory sits almost same, 50. Little bit 52 sometimes, peaking. Core is a little bit higher, let's say. Uh, 50 to 53. It's not much, just 3 degrees increase, and hotspot is now 60 when it used to be 56. Not that bad, I believe, as overclocking. Still keeping all the fan speed same, all the pumping speed same, everything is same, just all is the same. I believe we train exactly same amount of power also. $337 and it used to be, well actually we train 50 watts more. Not that bad. For some reason I don't get 100% load science. This doesn't stress the GPU that much. You can change the program soon where we test load more. Some other programs what I have. But let's start with this Heaven. This is actually free to download software. You can download this and benchmark yourself. But I have a couple other things to use. Even though this is quite an old software, but still looks amazing and still stress your GPU enough. So this temperature you can reach even overclock with just water cooling GPU. Well, a little bit higher score, okay. Not much, but still. You can see. And you can see the FPS. Actually, I got more dips on FPS now since I overclocked. So there's a big power draws also reason of that. Okay, that was the Heaven. Unity in Heaven, Wally. Let's test some other graphic. I believe it's here. Yeah. Hopefully this Cinebench yeah, Cinebench R24 has now also graphic card possibility to test your graphic cards. So let's see. Oh, wait a second. I reset my overclocking. I just set the power value as to max. So range as much as you can, but I didn't overclock it. So it's supposed to be. And let's check it out how much it stress my graphic card. It's allows to run. Let's wait until the one test run is done. You can see how much it's actually utilizing the GPU. Memory it's about 50, hotspot 52, GPU temperature, the core temperature 547, almost 50. Unstable hard 2800 Hz. I don't know how many runs I'm gonna do, but let's wait till I get the highest result. And also the GPU load is still under 100%. Maximum is 92. Sorry. quite amazing how much headroom water cooling gives your graphic card. So 10 minutes average runtime. It is 10 minutes what it takes. Let's add music in the mix. And sorry, I got pop-ups. My friends comes in online. How far the results come soon? It is about 20,736 point. Little bit deep in something. 20,500. But we kinda see the stable temperatures all around with using this Cinebench R24. Actually, if I would use the hardware info, you could see the liquid temperature to the thermal probes what I have in my system, which adjusts the actual fan speed is wrong. I don't actually have fans in my GPU because it's inevitable. Let's stop in this run. Okay. Okay. Wait and stop. Okay. That is good way to start. Let's a little bit clocks. Hopefully this doesn't crash. First run is always lie. Increasing memory clock and core clocks. Increase a little bit the points. Actually quite much. And the temperature is about same. $260. And the 66 is peak power draw, I believe. And almost 300. Yeah, 300 here. So let's say 40 watts more. I'm still trading more 40 watts as no power increasing 150 megahertz on GPU clock and memory 1000 doesn't increase much the temperature actually. It's almost the same. But unfortunately this doesn't give enough loading. Even though After this test we go with the Times by Extreme and check it out. That is you need to buy that software, unfortunately, but luckily I have bought it. $22,000 points. Let's do this run and change the now. 22,000 was the, I guess, highest score. These compares are, let's say, irrelevant. None of those are, well, this is consumer graphic card, but anyways, it's irrelevant. Since it's couple of generations old, but you can compare yourself in your, if you run yourself this same test, and you can let's say a little bit overclock, and you can compare how you are with aligned with me, my scores, and check the temperature. Is it worth it of water cooling your system? Not everybody benefits water cooling or has money to do so. And what was the? Let's open Steam and 3D Mark and check there what results we get from Times by Extreme. Unfortunately, the full screen test, which means I'm not able to share these values through the test, but I pressed the reset so we can check that. So let's start again with the non-overclock version with full power limits on. Full power on. And of course the Windows profile is high performance profile, and always if you are running games or tests or whatever, you should, well, unfortunately in this finish I can validate it's 4090 with rebar on, and also which what to say driver version I have currently, and I used 16 times 16 Gen 4 lines. And here when you do the settings, just always in a what to say power mode, would always prefer the best performance, not prefer more like a quality, put more like a performance, so you get more. Let's do the benchmarking, GPU, ultimate, office, say speed. But I have available so I have Port Royal, Times by Extreme, and Times by. Let's go Times by Extreme. customer. Get the GPU test. And if I can get the enable window mode. Yes. Now I can keep these on back. So a little bit performance I lost because I'm streaming, but as I said, I'm not rendering with my graphic card, but I'm testing because I have second PC which handles the stream, so don't need to worry about how much. OBS just gonna use a little bit more CPU that reduce the processing power to the actually. Let's wait the test to start. This looks so freaking ugly. I guess I do the full screen after this. At least now the load is higher. Really much higher. Where's the actual FPS? It used to be somewhere here, but now it's totally blocked. Sounds windowed mode. Let's do this run again. It's the second part of the test. As I said, I skipped the processing unit test, just testing the graphics. Sometimes I changed the paste, not paste because I don't have any more thermal paste in my GPU. I have a cry sheet and graphene thermal pad, and now I have also changed the thermal patch in the memory chips and VRAM on my GPU, so they're supposed to be for thermal transfer capacity. Since this GPU is almost 2 years old, it's nice to always maintain you. I changed thermal paste on my CPU and GPU every half year, but now I have cry sheets, I don't need to do so. Just keep your water cooled loop clean and that's it. What is the results? Well, 1200. Okay. That is what I unexpected. So let's try with overclocking. So I put same settings what before. Let's run times by extreme, except now full screen. So I reset this locks and let's run the custom. So now you can compare the results and also the temperatures. This usually takes always long because there's many of combination of the CPUs, GPUs and memory. Now it's full screen. It looks way better. And there's the FPS. CPU temperatures is in a 58. My Ryzen is running 60 in a hotspot. And let you know that Intel takes the readout on the surface and AMD take the temperature from the hotspot. They have different placing on the CPU probes. Hotspot is always higher than core surface. Stable 70, I believe, is the FPS. A little bit dipping, even 50. So times by extreme. Those who wants to test also RT cores, I will do the ray tracing test after this. So you got some kind of indicator on that. So secondary run. Oh, it was results already. Sorry. It went so fast. 13,900 points. It's a little bit overclocking. And you can see clocks were quite a much stable. Little bit dipping in the middle of the section, but that was the pass after pass 1. And the memory stable. What was the highest temperature? 64. Yeah, 64 in a CPU. 68. 71. 71 in a hotspot. Whoa. How much memory? Memory sits about 52. Yeah, 52. So now we reached even 70 in a hotspot. That's amazing. Let's do the ray tracing. With 0 overclocking. Let's go portrayal. Okay, full full screen. If I reset these settings, you can take a screenshot or something about this. I put in there. If you wanna take a screenshot, take it now. I'm gonna run the next tests. I reset the settings and the custom run now. All the standard settings. Again, it's on a full screen, so these is going the way. This is the last test runs what I do. First with the non-overclocked and then the same little bit overclocking, and let's do that. I got higher CPU usage, by the way, almost hitting 100 GPU. 90, 98, almost 99. Oh, 120! Whoa! I mean 120 FPS. And the secondary pass, I believe, there's... Oh, it's only one run. Oh, nice! Oh! Oh. So... you can take a screenshot. Actually... almost stable. Temperature was highest 58 point. Hotspot 68. Yeah, 68.6. And memory 54. Not much change. Couple of decreased here and then the power draw. Almost 400 watts. 380. It's like a toaster. But now I reset setting and I add overclocks and run the test again. Test again. let's say that 4090 is really expensive card, and especially if you manage to put on a water block. For comparison, in a time when I bought it, the graphic card it was 2000 euros. Water block was 520 euros, and I already have the custom water loop because I did previously have a graphic card also in a water cool. So basically, fittings and tubes and everything was already there. So basically, 2,500 euros just for water cooling the RTX 4090. In that time when I bought it, actually there wasn't any 4090 pre-assembled in the water cooling block, so available with the custom. So you need to buy graphic card separately with the water block. So I don't know why the manufacturer doesn't do these kind of things with the water cooling suppliers that often when they pre-launch some new tiers of products, which feels really stupid. It's more like anti-consumer behavior. I see something like 5 FPS, 5 FPS difference now. Was it 79.6 FPS or something that just right? So we can test the average on this. Yeah, let's say 4 FPS more. But the overclock. Somebody can say no. Somebody can say yes. And as a result, stable clocks, stable memory clocks. Here. Temperature, let's say 60 on the GPU. Hotspot 70. And 54. So about 2 degrees on the memory. Four degrees on hotspot. And 4 degrees on the GPU. As overclocking. Well under the X. So really good temperatures. While I overclocking quite heavily memory and core. So that's it for the benchmarking for the today. I wanted to do this after I have changed the thermal patch and also I don't have a thermal paste anymore in my GPU. I changed the cry seat. Changing the thermal patch to cry seats gives me benefit about 5 degrees on hotspot and 3 degrees to the GPU. I supposed to do this run before and after the maintaining my graphic card to the maintenance. So this is almost 2 years old graphic card for me. I have run this in the water loop at 2 years. So that's why I do the maintenance on my graphic card regularly. I use the I change the thermal paste every half years, but not fully. And now I just bought the cry sheet, so I don't need to change the thermal pads every half year. So, but bad thing in a cry sheet, since it's a graphene, it's highly electric conductive. So if you manage to have a board with the power and you manage to slip the graphene pad to the board, it might cause short or even broke the thing. So use the Kapton tape to cover the small caps all over the die. You know, there's small caps, electric components. So and put the cry sheet top of it, and it's good to go because Kapton tape covers it. And yeah, it is thermally resistant to these kind of temperatures. Kapton tape would melt in 120 degrees, and after that takes really high load of temperature in a board that it's gonna melt, and I would say it's well beyond that shutdown limit. Graphic card usually shutdowns itself in 110 degrees, depends of the graphic card manufacturer. AMD Radeon has 100 degrees shutdown, and Nvidia used to have 110. I don't know what is currently. So if it's exceeding 100 degrees, these are really